This is Srikanth, Assistant Professor of EEE Department. In this session, I am discussing the mesh analysis. It is the application of KVL. It is most powerful technique to calculate the loop currents inside the electrical circuits. Now we will see how and when we are going to apply the electrical circuits to calculate the loop currents. Here, mesh analysis is the method that is used to solve the planar circuits for calculating the currents at any place in the electrical circuit, and it is using the Kirchhoff's voltage law. By using the Kirchhoff's voltage law, we are going to calculate the currents. And mesh analysis is applicable only for planar networks, where planar circuits that can be drawn on a plane surface without no wires crossing each other. With no wires crossing each other. Here you can see this is the planar network. There is no crossovers. There is no crossovers from one element to another element. Where this is a non-planar network, where here we are having a crossover. And here also this is a non-planar network. And mesh analysis make use of Kirchhoff's voltage law to get set of equations where we can get the solution for the given circuit. And for writing the KVLs, first we need to check how many meshes are there or how many loops are there in the given circuit. First we need to check how many loops are there. Then after we have to assign the direction as well as the magnitude of the currents. That is, we are going to give some current magnitude as I1, I2, I3 or IA, IB, IC or IX, IY, IZ. In any way we can represent the magnitude of the currents. Those current magnitudes we are going to calculate. Now, how many mesh equations we are going to get? That is equals to number of mesh currents, that is equals to branches minus number of nodes minus 1. Branches minus number of nodes minus 1. And we have to solve the mesh equations to get the mesh currents. Finally, we'll get what is the current flowing through each loop. What is the current flowing through each loop? And also voltage across each element. Anything we can calculate when we know the current flowing through the element. Now let us take with a example what is the procedure we are going to follow, the complete procedure. Let us discuss with the basic example circuit. So here this is the circuit which we are having, and in this circuit we are having which is going to form two loops. One is with Vs R1, R2, and another loop is with R2, R3, R4. So here we are having two loops. So the two loop currents we have to give. The direction I am choosing which is a clockwise direction. That is the easy method. We can write the KVLs easily. So this is the current direction, and loop 1 current direction as I1 and loop 2 current direction as I2. Now we have to write the KVL. What is KVL? Kirchhoff's voltage law. That is, algebraic algebraic sum of voltages in closed path is equal to 0. Algebraic sum of voltages in a closed path is equals to 0. Here, how we are going to write the algebraic sum? Here, when we are going to write the algebraic sum, we have to consider the sign convention into consideration. So, sign convention for any resistor, the voltage drop across the resistor can be taken as whatever the current which is entering, that terminal we are going to take it as positive and the leaving terminal will be taken as negative, and this is the voltage drop across resistor 1. And here we have to check this. Okay, what is the voltage across R2? But here while writing loop 1 equation, because this R2 resistance is connected with both the loops. So when we are writing KVL for loop 1, then we have to consider the I1 current has higher magnitude, so that the resultant current will be flows through this in this way, that is in the downwards. So this terminal is taken as positive. When you are writing loop 2 current, loop 2 KVL, you have to consider I2 current has higher magnitude, that is secondary loop current has higher magnitude, then the voltage across the R2 will be, this will be plus and this will be minus. Okay, so first let us write the KVL in the loop 1. KVL in loop 1. KVL in loop 1. Here, when the current enters the negative terminal of a voltage, then you have to consider it as negative. When the current enters the positive terminal of a voltage, then you have to consider it as a positive. So here current is entering the negative terminal of source voltage, so minus Vs, and here current is entering the plus VR1 plus VR2, which is equals to 0. That is equals to Vs is equals to VR1 plus VR2. What is VR1 and VR2? VR1 is nothing but voltage across the R1 resistance. When we take voltage across R1 resistance from according to Ohm's law, V is equals to IR. Here in this resistance, in the resistance R1, only I1 current is flowing through it. Only I1 current is flowing through it. So VR1 is equals to I1 into R1. VR1 is equals to I1 into R1 plus VR2 is equals to, so in the R2 resistance, two currents are flowing. One current is flowing in this particular direction and another current is flowing in the opposite direction. So here which current has high value, that will be positive and the other will be negative. Here when we are writing the KVL for loop 1, when we are writing the KVL for loop 1, we are assuming that I1 has higher magnitude. So that is equals to I1 minus I2 into R2. That is equals to I1 into R1 plus R2 minus I2 into R2 minus I2 into R2. This is the voltage equation, that is loop 1 current, loop 1 KVL. This is equation number 1. Now let us write the KVL in loop 2. KVL in loop 2. That is KVL in loop 2. KVL in loop 2. Now we are assuming that I2 current has higher magnitude. I2 current has higher magnitude. So here the current flowing through, resultant current will be I2 minus I1 into R2 plus I2 into R3 plus I2 into R4 is equals to 0. Here minus I1 R2 plus I2 into R2 plus R3 plus R4 is equals to 0. Now we got, this is the equation in terms of I1, I2. This is equation number 2. Two equations, two unknowns, R1, R2, R3, R4 values and Vs values are given. We have to calculate I1 and I2 by solving equations 1 and 2. By solving equations 1 and 2, we will get I1 value and I2 value. This is the way we are going to calculate once the value of resistances and voltage source are given. Now we'll go with the values. By giving the values for the resistors, how we are going to solve the equations. Let us see. Here, this is the circuit which we are choosing in order to calculate the currents flowing through the loops. Here, first, immediately once the problem is given, we have to check what are the things we need to calculate. We need to calculate, find the loop currents, voltage and current through each element in the given circuit. So first we need to calculate the loop currents, then after we'll calculate voltage and current through each element in the given circuit. So here first we need to check how many loops are present in the circuit. Here we are having two loops in the given circuit. This is the loop 1, that consists of 28 volts, 4 ohms and 2 ohms. And this is the loop 2, which is going to have 2 ohms, 4 ohms and 7 volts. Now the loop current directions I am taking in the clockwise direction. Whatever may be the circuit, let us take the clockwise current direction and we will write the KVL. So that these are all, whatever the directions are our assumptions. Based on the exact values, we may get the positive value or the negative value for the currents. If the actual current is in the reverse direction, then we are going to get minus value, negative value. That indicates that the current is in the reverse direction. So here, this is I1 and this is I2. Now let us write the KVL in loop 1. KVL in loop 1. That is, current is entering this is positive and this is negative, this is positive and this is negative. Just whatever the line in the battery, the line which is having the maximum length, that is higher length, then that is taken as the positive and small length is taken as the negative. So here current is entering the negative terminal of voltage, that is minus 28 plus 4 into, which is current flow, voltage across the 4 ohms is nothing but current flowing through it multiplied with the resistance. That is 4 into, what is the current flowing through it? I1 plus 4 into I1 plus, here when we are having a resistance which is connected with both the loops, then we have to consider whatever the loop current we are writing, that current has higher magnitude. So we have to write 2 into I1, and I2 is in the opposite direction, so it is minus I2, that is equals to 0. That is 4 plus 2, 6 I1 minus 2 I2 minus 2 I2 is equals to 28. 6 I1 minus 2 I2 is equals to 28. This is our equation number 1. And next, let us write the KVL in loop 2. KVL in loop 2. That is, when we are writing the KVL in loop 2, we have to assume that I2 current has higher magnitude. So that is 2 into I2 minus I1 plus 1 into I2 plus 7 volts, because current is entering the positive terminal of voltage, which is equals to 0. Now we'll get minus 2 I1 plus 3 I2 is equals to minus 7. This is equation number 2. Now we got the two equations and two unknowns. We can solve these equations. By solving these equations, we are going to get, by solving equations 1 and 2, by solving equations 1 and 2, we are going to get the I1 and I2 values. Get the I1 value as 5 amperes, I2 value as 1 ampere. Now we got I1 and I2 values. Now we are going to, these are the loop currents we got, that is I1 and I2. Now we need to calculate what is the voltage across each element and what is the current flowing through each element. Now let us go with the calculation of voltage and current through each element. So for that I am redrawing the circuit. Seven volts, 28 volts, 2 ohms, 1 ohm, 4 ohms. Here we got this current as I1, which is 5 amperes, and this current we got it as I2, that is equals to 1 ampere. Here, when we got this is I1 as 5 amperes, I2 as 1 ampere. Current, what is the current flowing through? 28 volts. What is the current flowing through 28 volts? That is, only one current is flowing because no other path for the current. So the current flowing through 28 volts is 5 amperes. And what is the voltage across 28 volts? It is the source. Okay, voltage across 28 volts is same 28 volts. Now, what is the current flowing through 4 ohms? What is the current flowing through 4 ohms? The current flowing through 4 ohms is here in the 4 ohms. Only one current is flowing, that is I1 current. That is I1, that is equals to 5 amperes. Where Voltage across 4 ohms is nothing but 4 into 5, that is equals to 20 volts. Voltage across 4 ohms is equals to 4 into 5, that is equals to 20 volts. Now we need to calculate what is the current flowing through 2 ohms. Current flowing through 2 ohms. For this, we need to give our current direction. Okay, because when we are writing KVLs, we have taken in a different way such that loop 1 current has higher magnitude and loop 2 current has higher magnitude. But here we have to give some current direction which is flowing through the 2 ohms. So in that particular direction we have to calculate. In the downward direction, in this particular direction, the current which is flowing is I1, and in the opposite direction I2 current is flowing. So I1 minus I2, that is equals to 5 minus 1, that is 4 amperes. 5 minus 1, 4 amperes. So this is the I2 ohms current. Now what is the voltage? Voltage across 2 ohms is 4 into 2, that is equals to 8 volts. Current flowing through 2 ohms is equals to I1 minus I2, 5 minus 1, 4 amperes. Voltage across 2 ohms is 4 into 2 volt, 2, which is equals to 8 volts. Now we need to calculate what is the current flowing through 1 ohm and 7 volts. Current flowing through 1 ohm is, here is only one current is flowing in the 1 ohm, that is I2 current. That is I2 current, that is equals to 1 ampere, and voltage across 1 ohm is equals to 1 into 1, that is equals to 1 volts. When the current is just current across 7 volts, 7 volts current is 1 ampere. Here also we have to mention the current direction, current flowing direction, and the voltage will be, voltage across 7 volts will be 7 volts. These are the current and voltage values across each and every resistor or each and every element in the given circuit. This is the way we can easily calculate by using the mesh analysis. Now we'll go with another circuit, that is with the different combinations of resistors and voltages, and how we are going to calculate the loop currents. Let us see. Here in this we are having two loops, that is the current directions we have assumed as I1 and I2. We have assumed as I1 and I2. Now let us write the KVL. Now let us write the KVL. KVL for loop 1. KVL for loop 1. So KVL for loop 1 is nothing but algebraic sum of voltages in a closed path is equals to 0. That is minus 15 plus, here current is entering the negative terminal of voltage source, minus 15 plus 5 into I1, 5 into I1 plus, here this is the 10 ohms which is connected with both the loops. This 10 ohm resistance is connected between the two loops. So here we have to check the current values. When we are writing the KVL for loop 1, we have to assume that I1 current has higher magnitude. I1 minus I2, I1 minus I2, that is equals to, so here another element is also there. another voltage source is present between the two loops. So when the current enters the positive, positive we have to write. When the current enters the negative, we have to write negative. Here the current is entering the positive value of voltage plus 10, which is equals to 0. That is equals to 5 plus 10, 15 I1 minus 10 I2 is equals to 5. This is our equation number 1. Now let us write the KVL for loop 2. KVL for loop 2. When we are writing the KVL for loop 2, we have to assume that I2 current has higher magnitude. That is minus 10 plus 10 into I2 minus I1, because I2 current has higher magnitude and I1 current is in the opposite direction. 10 into I2 minus I1 plus, here the current flowing through 6 ohms is only I2 current, 6 into I2 plus 4 into I2, which is equals to 0. Now minus 10 I1 plus 10 plus 6, 16 plus 4, 20 I2 is equals to 10. This is our equation number 2. By solving equations 1 and 2, I1, I2, 1 ampere and 1 ampere. So we got I1 and I2 values are 1 ampere and 1 ampere. So here no current will flow through this branch. I1 minus I2 value will be 0, or I2 minus I1 value will be 0. So no current will flow through this branch, that is 10 ohms and 10 volts source. This is the way we have to calculate the loop currents by using the mesh analysis. Now let us go with till now we have discussed two loop mesh analysis problems. Now we'll go with three loop mesh analysis. That is 15 volts. These are the three loop currents, where three loops we are having in this particular circuit. When three loops are there, we have to give three loop currents, that is I1, I2 and I3. The procedure for writing the KVL is same whether you are taking two loops or three loops. Two loops or three loops. So now let us write the KVL for loop 1. KVL for loop 1. That is minus 15 plus 4 into I1 plus, here 2 ohms is connected between loop 1 and loop 2. 2 into I1 minus I2, which is equals to 0. Now 4 plus 2, 6 I1 minus 2 I2 is equals to 15. This is our equation number 1. Now KVL for loop 2. KVL for loop 2. When we are writing the KVL for loop 2, we have to assume that loop 2 current has higher magnitude. Here there are no voltage sources, so all drops will be positive. So here if you write the voltage across 2 ohms, that is 2 into which current has higher magnitude? I2 current. I2, and opposite current is I1. I2 minus I1 plus 6 into, in the 6 ohms only I2 current is flowing, 6 into I2 plus 10 into I2 minus, here current which is flowing in this direction is I2, in the opposite direction is I3. So 10 into I2 minus I3 is equals to 0. Now minus 2i1 plus 6 plus 2, 8, 18i2 minus 10i3 is equals to 0. This is our equation number. Now let us write the KVL for loop 3. KVL for loop 3. KVL for loop 3. Here I3 current has higher magnitude. So 10 into I3 minus I2. Opposite current here is I2 plus 8 into I3 plus 12 into I3 is equals to 0. Minus 10 I2 plus 30 I3 is equals to 0. This is equation number 3. Now by solving equation 1, 2 and 3, we'll get I1, I2 and I3 values. Now we got the values for I1, I2, I3 as 2.61 amperes, 0.35 amperes and 0.11 amperes. This is the way we have to calculate the loop currents and current flowing through each element in the given circuit by using the mesh analysis. So in this session we have discussed how to calculate the loop currents using mesh analysis and also how to calculate the current flowing through each and every element in the given circuit by using mesh analysis. Thank you. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.